Hello and welcome to today's session. We are really excited to have you join us today to discuss organizational growth, data management, and cloud adoption. My name is Paul Nashawaty, and I'm a senior analyst at Enterprise Strategy Group, and I cover application and infrastructure modernization. Today, I'm joined by Craig Theriac. Craig, would you like to introduce yourself?
Yeah, thanks, Paul. I'm Craig Theriac. I'm the Vice President of Product Management at Scale Computing. I have been with Scale for, 12 years now this June, which is hard to believe. Kind of grew up through several different product management areas within Scale, and then the last 2 years have taken over the team all the way through in the introduction of what we call Fleet Manager, which we're real excited to talk about today.
Absolutely, Craig. I'm really excited to be here to have this discussion. So let's jump in. So as we get started, let's review the discussion and what we're looking at. So as we're kind of looking through this presentation, we want to talk about how edge computing is important to understand the growth. It's really a growing area. It's really exciting. There's a lot of data to unpack here, so we'll get into that. Next, we'll talk about some of the common challenges that IT and infrastructure teams, they really must address. These are some of the common challenges. They're not all the challenges, but we don't have a lot of time, that much time in this video, but we have some of the key areas we do want to bring up. Next, we want to talk about hybrid clouds, the deployment and the process of information, basically processing that information in location, because as data grows and as we see those challenges happen, we'll see that there's a lot of information to process. So lots to unpack here. So let's just go ahead and jump right in. So as we get into the first part of this webinar, we'll discuss the growth of edge computing. We find in our research that core data centers are not growing or expanding, but the edge locations are taking on more responsibilities. So let's take a look at this data. If we look at this slide, we can see that edge locations growth is on the rise, okay? What we see in this slide here is the light blue is representing the today's information, but the dark blue is actually showing that growth trend, and the dark blue is showing that's 2 years, and so for the next 2 years from now, how organizations are viewing their worldwide edge locations. So core data centers, as I mentioned, are not growing, and the infrastructure is moving to alternative smaller locations. In fact, we see in our ESG research that there's a significant growth in edge locations over the next 2 years, as I was talking about with that dark blue slide. 30% of the respondents indicated that the organizations would be growing to 500 to 1,000 locations in edge locations over the next 2 years. So substantial growth there. And with this growth, we see that latency, compliance, and cost factors are where organizations are challenged at the edge. But combining that with limited to little or no IT staff, physical constraints tie up connectivity outages and lead to unpredictable demands. So Craig, the number of edge locations grow. How does scaled computing deal with these challenges?
Well, first, let me just say, I think you nailed the issues that we see in edge computing really well. I mean, if you've concluded that you can't use public cloud resources, and there are lots of reasons to use public cloud if you absolutely can, but if you concluded you can't, and you're now deciding, hey, I need to deploy this on premises, you've got some unique challenges to address. It really comes down to the fact that the edge environment is not a tier 1 data center, right? It is not, it's not pristine, it's messy, it's ugly. The first thing I think you'd said, Paul, was that there's little to no IT expertise on site. If you are deploying these in an area where you don't have someone with IT expertise on site, you have to so just kind of looking through your survey results here, Paul, I think it says managing infrastructure and deploying, modernizing, and servicing infrastructure is 2 and 4 on the list here. It absolutely makes sense to me. If you are deploying these in an environment, you don't have somebody on site to handle infrastructure issues, and I mean things like drive failures or node failures, or even just the initial deployment, it becomes expensive. You have to compensate with managed service providers, or maybe for on-site support from whatever OEM you've purchased your hardware from, and that gets costly. So really what you need is a solution that is easy to manage, easy to set up, remotely managed with, in our case, a fleet manager product that allows you to see across your entire fleet of systems out there at the edge. The second group of challenges that I would say that would encompass, I think you'd referred to them as just physical constraints, and that's everything from power and cooling, which I think you can see down near the end of the survey results there, which is fairly common that we'll hear somebody say, I've got to make sure that I have sufficient power or cooling in this area because they're going into hot, messy areas. It can get a little ugly. But what people don't commonly think of in these environments is securing the infrastructure itself. You imagine, putting out point solutions across hundreds to thousands of sites, and all of a sudden, every new solution you put in, every new physical piece of hardware has just expanded the attack surface that you have for things like ransomware. And so security, not surprising to see that at the number one of the list. It's out of your hands physically, and that means it needs to be more secure than it would be sitting behind probably an armed guard in a tier one data center that you might be managing elsewhere. The other thing that we commonly hear is that a lot of these sites don't have a reliable internet connection. Right, so there is a need for autonomy. You need to be able to set something up that's going to provide the high level of uptime you need for the workloads through high availability or whatever mechanisms you have in place. And again, without a local administrator to provide that, it's very common that these would be deployed in remote parts of the world, or even remote parts of the U.S. I commonly will talk to retailers that say, well, that's out in Podunk. I can't count on the internet connection. It's the least kind of the most likely thing to go down in that environment. And so because of that, I need to make sure that I have some level of autonomy in my infrastructure. And then the last thing, which I don't think is really reflected in your results here, but I commonly hear from people in charge of the infrastructures, is they don't necessarily know what's coming down the pike for them. They understand, a lot of them already have remote office, branch office type solutions in place. They might be running file print, that sort of thing. So they've got these legacy VMs. They need infrastructure to run that. They may be working alongside their development team or DevOps teams to deploy new container-based workloads or kind of cloud native workloads on the same infrastructure. But what they don't know is what's coming in the future. They may have some idea of, that team's working on something related to machine learning, maybe inference, computer vision, and without visibility into that, you need infrastructure that provides the flexibility to adapt to whatever those workloads are that come down the pike. And so that's essentially what the scale computing platform is a solution that addresses those types of challenges. It's everything you need from what is running on premises. So we have what we call SC platform, scale computing platform. It's really broken down into two pieces. One is SC Hypercore. So that's Hypercore is the software that's running on premises on the nodes themselves. It provides high availability, kind of everything you need from the virtualization layer, storage layer, combining all of that into an appliance-like form factor. Those of you that are familiar with HCI, this would fall into the HCI space. And then we pair that with what we call SC Fleet Manager. And SC Fleet Manager is a cloud-based resource that allows you to manage and monitor all of these, this fleet of hypercore systems at scale. So not just for a single site, but again, hundreds of sites, all managed, orchestrated, monitored from a centralized view.
Yeah, Craig, you've touched on a lot of points there, and I kind of led that conversation, that question with that limited IT staff and such. But I was looking at some of our other research as we're talking about this. 67% of organizations in one of our recent research studies indicated that they were actually hiring IT generalists over IT specialists over the next 12 to 18 months. And at the edge location, sometimes there's just no technical resources available. And you touched on the physical constraints, the network connectivity problems there. All those areas are really, it comes down to complexity and then ease of use. And I really think that's an area that edge locations can really benefit from a solution like Scale. I think another area that I look at is I like to ask you the question around what does this mean for specific use cases like shipping and transportation? Because I think that sounds like a good area for using this type of solution. What do you think?
Yeah. Well, first of all, every industry has some type of application that they're looking at the edge right now. Manufacturing, retail, you name it. But I love transportation. I love talking about that because it's just it's a little edgy. If you'll allow me to use that, it's about as edgy as it gets. Right. It is sitting. We have customers right now that are deploying these small form factor edge computing clusters on their fleet of ships. And these ships, of course, are going in and out of international waters. They may or may not have cell phone connectivity. If they do, they've got pretty high latency, pretty low bandwidth. And if they don't, then they're just kind of sitting there without any connectivity. And so given that, they have to run mission critical applications like accounting and cargo management, crew management, planning, maintenance systems, crew training and simulations, like all things that required by regulation have to be on the ship. And application downtime just can't be tolerated in that. And so where scale computing platform fits in is, again, we have Fleet Manager, which is sitting across, looking out at the entire fleet of hypercore clusters out there. And then we have hypercore running on these smaller form factors they have sitting on ships. And course, they're out at sea. What happens if a drive fails? Not a big deal. If a node fails, not a big deal. Those applications that are critical stay up and running, and the people that are relying on those applications don't have to automatically turn the boat around, go into port, and replace hardware so they can do their job. So that's really, in the context of that use case, I think that's where scale computing shines.
Yeah, absolutely. And that makes a lot of sense as well, because like I think about the delivery. I think about these environments that the shipping and transportation. You mentioned ships, and so I guess the question is there a need for a ruggedized approach? Like what happens for the delivery with I should say with regards to a ruggedized approach?
Yeah, I would say in many edge environments, ruggedized approaches are required. The edge is not a tier one data center. It is dusty. It is hot. It's messy. In the case of those ships, I had several conversations about what happens with salt in the air, salt water, and kind of how that interacts with things. And so there's just different things you have to take into account whenever you're deploying out at the edge. One of the ones that's commonly overlooked, though, is noise. It's not just the cool applications we're all talking about are IoT devices that are collecting data and they're sending it back, and it's just sitting on a manufacturing floor next to this giant machine and lots of really cool things. But it's very common that these are going into like a retail environment where you're supposed to have a conversation with the customer, and you can't have the whir of the fans and the server sitting right next to you. And you have to take into account things like that. So I keep looking over to my left here because I actually have one of our HE150 nodes. I don't know if you can see that, Paul, but it's a NUC-based platform, really small form factor. This is commonly deployed in a retail environment like that. And I can tell you, I've got a cluster of these sitting on a shelf in the room next to me here. And I can tell you that in my home edge environment, that if that thing were loud sitting next to the TV or cause some spike in power, the natives would be restless and I'd have to get rid of it. So I've had that thing for a year now and no complaints yet. So those are the types of concerns you have to take into account, though.
No, for sure, for sure. And since we're talking about infrastructure, and I appreciate the conversation here, this is great. But let's take a look at those infrastructure challenges as we move forward. We've had a lot of great discussion so far around the edge, around what's happening there. But we also should look at those organizational challenges as well. And some of those organizational challenges actually impact the infrastructure as well, right? So to understand these challenges, the next logical question is, well, how are they being impacted? And what are the requirements needed for them to be resilient, right, across their organizations, right? So let's take a look at some of the data. And this is just a few data points that I pulled to consider. One challenge sometimes overlooked is storage storage growth at the edge, right? This is a factor when we think about IT infrastructure. But with that said, it's most likely to be thinking, when we think about the storage, we think about it in the context of the growth of storage, but we also have to think about it, as you mentioned this earlier, about different use cases like finance and retail and healthcare, all these different, large data consumption kind of remote areas. The data does need to be processed in place. If we look at this slide here, we're looking at 25% of respondents indicated that they have 2.5 petabytes or more of storage at their combined edge location. That's a lot of storage to be processed. And the days of moving information back and forth, are basically you just can't do it anymore. There's just the volume of data is just too much. So like advanced use cases, we talked about this, Craig, you mentioned AI and ML at the edge. This would help. AI and ML would actually help a lot of industries such as retail, healthcare, finance, pharmacy, transportation, deliver those fast results that they're looking for. So, I think that's something to consider. And then when we also look at, basically connecting this with the last slide, you can see the annual growth of storage. This is based on this study, that the annual growth of storage over the next 3 years at the edge is not slowing down. And actually, we see that growth of over 3 petabytes of storage at the edge in the next 3 years, according to this ESG research. So, but storage is only one of the challenges, right? And there's inconsistencies in the infrastructure that's also important to explore. But before we move on to the next challenge, Craig, what are your thoughts on storage?
Well, I think you just look at the drivers of what's causing edge computing, the volume of data that's being generated out of the edge, and the stats that you have on screen here. That's why people are putting infrastructure out of the edge, and the challenges that you get from that, and the fact that now it's hard enough to manage 2.5 petabytes in a centralized data center. Now, having that dispersed across hundreds of sites, that can be a challenge. So that's kind of where my head's at with it is we are also seeing the same storage growth. And again, a lot of times it is related to the AI machine learning type of workloads that are generating that volume of data. And we only expect that to grow over the coming years.
For sure, for sure. And and I also think that when we look at storage, the infrastructure as a whole is also important to consider. When we think about repeatable and deployment, we talked about that IT skill gap. We talked about those challenges of consistency of deploying. So organizations are often focused on rapid time to value, right? That's one of their main kind of drivers to get their infrastructure running. But they want to run these, deploy these infrastructures in ways that they can have a consistent, compliant, and repeatable within their environment. So leveraging like infrastructure as code is a repeatable way to deliver secure compliance infrastructure, right? And also you can limit your IT staff from not having to do those kind of mundane tasks that they had to do. They can use those blueprints, so to speak, to drive those deliveries forward. So in fact, in our recent ESG research, we found that organizations currently utilize infrastructure as code templates as part of their approach to cloud. You mentioned cloud native, right? To deploy their cloud native application deployments. We had a high response, right? We see that 62% of respondents indicate that they use an infrastructure as code extensively or in a limited fashion. But when it comes to these issues, the organizations are also experiencing scaling, and using infrastructure as code helps with that. 57% of respondents indicated that they want to ensure quality and consistency across the teams as well. So it's not just about making sure you have a compliant infrastructure, but it's also that collaboration, making sure that there's a repeatable process so the teams can actually deploy as well across that way. But it's not all there. That's not all of that is required with regards to challenges and such. IT organizations and infrastructure teams, they have to address many, right, when it comes to the edge and such. But Craig, with all these challenges, how does Scale address the low latency and potential connectivity issues or outages with the customer environments? You mentioned the networking downtime. So I just wanted to double click a little bit more on that.
Yeah, no, it's a good question. I mean, well, in general, I would say the movement of edge computing is how we address low latency. It's, by physically moving the compute and storage closer to the people and things that are interacting with it, that are processing data, that are generating data. That's how you get the low latency when compared to cloud resources, I would say. So that's not unique to scale computing specifically, but that, just in the nature of how things are deployed, we would see lower latency. Now, having said that, this NUC that I keep pulling up here, this is an NVMe based NUC. It's about as low latency as it gets these days running on NVMe. But again, nothing remarkable about that other than the fact that it is a smaller form factor that's able to produce that. But I would say where our scale computing platform really shines, though, is in hypercore. So the software that is running on these nodes, it has a lot of intelligence built in, and we don't really dig into it too often, but I'll do it slightly here now, which is that we call state machine technology, and the state machines are really designed to be able to, in this really complex environment, figure out the lay of the land and understand, here are the current conditions, here's my current state, here's the desired state that I'd like to get to. And these state machines don't necessarily have to have an internet connection. In fact, they just operate there autonomously on their own, right? So those state machines are constantly running. And so as things change in the environment, the drive fails, the node fails, you name it, exhausting memory, MCE, whatever the issue is that might exist out in that environment that would historically have required an IT administrator to have to go out on site or remotely diagnose something. These state machines are designed to identify, correct, and at least get to the best possible state that the system can get to, given whatever the current conditions are. And so that's really the intelligence, having that in locally and not requiring kind of a layer above that to make those decisions is where scale works. And that, the maritime conversation we had earlier, that's why that's able to happen. You can put these on a ship knowing that you don't have internet connectivity. In retail, I commonly hear people that are deploying in remote parts of the world. They've got 80% of their retail sites are in great areas, but then the other 20%, they may not be able to rely on the internet connection. So you need that level of autonomous operation.
No, absolutely. And, and I'll kind of frame or paraphrase something that you didn't use these words, but I heard you say reduces complexity, ease of use, right? I heard those words come out of your mouth, right? Because when I hear about, the challenges organizations run into, they're always met with these challenges of trying to deploy quickly and not having to really know how, right? And I'm not saying that they just don't know have the skill set, or they don't, some of those challenges are real, but a lot of the challenge is what to do next, right? Organizations spend a lot of their time in maintenance mode, probably 80% or more of their time in maintenance mode, right? Probably less than 20% of their time in innovation, right? So when we look at that, providing an ease of use solution for their IT organizations to deploy and stay and innovate, like be innovative, that's really important, really key. So I think that's what I heard. I don't know if I put words in your mouth there, Craig, but
Yeah. No, that's an interesting take on it. I would say yes, that is absolutely the case. I mean, ease of use is. I mean, you'll hear us talk about it all the time. It's why we have trial programs to get this into the hands of people, because people just don't believe how easy it is until they are physically interacting with it and understand. It's like, oh, this actually does work exactly how they say. But I would say that the innovation comes, yes, from the IT teams that are developed. They're able to spend their time doing other things, but it's also, this is a platform that can be used for DevOps teams at the end of their CI/CD pipeline. I mean, this infrastructure of code movement, you've got to be able to give people the tool set where they don't necessarily have to bother the infrastructure team. They can just have at it with the underlying platform, knowing that it provides the resiliency they need for their applications to run on top of it.
Absolutely. So with that said, let's jump into the next topic, the last segment of the session here, because I think it ties into the DevOps discussion, right? It ties into the cloud usage, right? So when we ask respondents of how they use or organizations that are using hybrid cloud application delivery and how production applications were being deployed, 46% of respondents indicated that their organizations have been deploying multiple production applications in a hybrid cloud model, and 31% indicated that they're deploying single production applications in a hybrid cloud model. So clearly, the hybrid cloud model is the adoption is growing. Organizations are looking to scale this type of delivery model. So let's talk a little bit about this data as well. And when we look at the market landscape, I know this is a pretty busy slide, but as we look at the growing in terms of cloud native and cloud adoption, we talked about the different types of applications. We talked about how organizations are working. We see that organizations are currently deploying 88% of their production applications and server workloads on public cloud infrastructure or platform services. We also find that infrastructure as service or platform as service is the preferred method for cloud native application deployments. But organizations are not just deploying in one cloud. In fact, we see 31% of organizations indicate that deploying on many unique public cloud infrastructure service providers, having a distributed cloud or multi-cloud approach is important to cloud native strategies. What I like about the right side of this slide is this is showing 89% of respondents indicated that they're running on 2 or more CSPs. That's just telling right there. And when we look at what the CSP means, that could be different public cloud providers. It can also be a hybrid cloud, an on-prem cloud, or an edge location. So the cloud can be multiple different locations. So but providers are also they're trying to differentiate themselves, right? And they're trying to augment their foundational container orchestration. They're providing capabilities such as distributed management of multiple clusters, serverless capabilities, application lifecycle, integration, policy management, monitoring, and security. Those are just to name a few, right, of the areas. And this can also require organizations to expend a lot more resources to navigate these additional services, right? So they really have to kind of figure out how to take all that into consideration and then manage it appropriately. So Craig, when I think about this data and I think about the information from this study, I understand that organizations are looking to use cloud and on-prem deployments the same, right? So like there's a lot of a hybrid approach that we're talking about. What are your thoughts on this?
Well, first of all, it's when I first read this, I thought, oh man, I cannot believe how many people are using multiple CSPs. But then you start digging into the definition of it, and it's like, oh, well, of course they use multiple CSPs. If you define, your cloud service provider as the Amazons and Googles and Azures of the world alongside the private cloud or edge infrastructure, it makes sense that they would have multiple, especially given that you said real quick in passing something along the lines of you need to be able to treat all this infrastructure the same. You want to be able to manage it in the same way. They all have unique challenges. I mean, that's kind of what we've been talking about today, but to be able to manage them the same, I think and interact with them in the same manner is key to this. And so that where my head goes with it is the edge computing infrastructure that we provide needs to be thought of as a cloud. Honestly, it's got the cloud-like simplicity of being able to deploy it, and you just don't worry about the infrastructure. It just kind of runs itself, and that's, I think, what a lot of people are drawn to cloud for. But it also has the lower latency from just having been deployed on premises. And so we kind of have we call a edge to core to cloud strategy, and how we fit into this overall landscape of computing. And obviously we've spent most of the time today talking about being edge ready and having these edge solutions, but we're commonly deployed in primary data centers as well. We've got 1U, 2U form factors, whole bunch of storage, whole bunch of compute. They can provide that level of a cloud-like experience in a data center. But I think where things get really interesting is in this hybrid cloud area, where people are looking at sometimes it's simple as, hey, I've got a file server. I want to run Wasabi. I want to run Azure File Sync as a local cache on something close to the people that are interacting with that data. And then on the back end, I'm tiering off for an archival tier of storage that's deep and cheap and kind of get all the benefit of the cloud from that. All the way through to more of the advanced things, which I think was a lot of what your slides, the last couple of slides have been about, which is really around that CI/CD pipeline and DevOps teams, and providing a platform that allows them to interact with the REST API that is complete with things like Cloud in it, so where these teams of people can treat it as code and say, okay, here, let me declare what I want that environment to look like, and at the end of it, know that it's going to look exactly like I want it to. And yet I can continue to use the same tool set that I've always used. So container management systems like IBM Edge Application Manager, Portainer, Avasa, Google Anthos, those types of applications are still just as relevant in the edge side as they are, the core as well as cloud.
Yeah, I think you addressed this, and I was thinking as you were talking, addressing the challenges from the data center core to edge to cloud, and using that harmonization of tool sets that basically allows you to balance out your ecosystem appropriately, like really understand and harmonize across the different locations. I typically say at a lot of my discussions around cloud in the future, we won't be using any word leading up to cloud. It would just be cloud, right? So whether it's a data center, it's a cloud. If it's a public cloud, it's a cloud. If it's a hybrid cloud, it's a cloud. So we're just going to say cloud moving forward instead of saying, all these different qualifiers to say what it is. But right. I think it's important that we have a unified approach, like you're talking about here, Craig, which is one unified approach to manage the core to edge to cloud appropriately.
Right. And just use the metadata of what about those resources to decide where you want to place that application. If it needs low latency, run it on-prem. If it doesn't, it needs elasticity, run it in the cloud. And that's the ultimate strategy.
Absolutely. And then you get into other reasons like compliance and regulations, data sovereignty, and all sorts of other reasons that you would want to have a kind of that, again, hybrid approach. And, as we kind of think about this, you mentioned the CI/CD pipeline and the same lines of the management, there's also the discussion of the importance of application portability, right? And when you look at application portability, we find that in our research that 19% of respondents indicated that application portability is critical, and 67% of respondents indicated that's very important. Now, out of that percentage that I just mentioned, that's not reflected on this slide, by the way, 30% of the respondents from that follow-up indicated that they're running exactly to what we were talking about on the previous slide on a public cloud, edge location, and private data center. So they're running across these different locations, and application portability is key. And hybrid cloud strategy and portability have a connection, right? So in order to have that kind of pull it together and tie it together, it makes a lot of sense to make sure that the applications can work uniformly across the different locations. And again, it also comes back to processing that data in place because of the size of data, but providing accessibility to the place is a key factor, right? So having access to that information online, offline, or whatever it may be, that information needs to be accessed. So Craig, what are your thoughts here?
Well, I would say the first thing I thought of when I saw this is just portability is the driving factor behind containers, cloud native, like that entire movement. If you ever have a chance to talk with developers directly about their passion around this, it really comes down to the pain points that they always had in a monolithic application design, right? So they developed something on their own laptop, they pushed it into QA, it would break, there'd be some dependency issue, they'd finally fix that, and would go to production, something else would break. And just this chain of dependency doesn't exist in this cloud native world that people are developing in now. And so, and that really comes down to the portability of the containers that they're creating, right? So it's everything that it needs packaged together. Doesn't matter if it's running on the laptop, doesn't matter if it's running in QE, doesn't matter if it's running in production, doesn't matter if that production is public cloud, doesn't matter if that production is the core data center, doesn't matter if that production is an edge-ready solution like our scale computing platform. As long as you can rely on the underlying infrastructure, you should be able to interact with it all the same. So yeah, I think that is crucial.
Yeah, spot on. I mean, and that's it. Organizations really don't care about all the individual pieces. They just want it to work, right? They just want to make sure that they can move forward. And if we're, providing solutions that make it work for them, then they're happy, right? And if it's easy, even better, right? So, look, we can talk all day on this. I know we've had many conversations, many briefings on this, and I've enjoyed our time together. But as we start to wrap up here, I'd like to just kind of recap on some of the topics that we're discussing here. So we talked about the growth at the edge, right? We talked about some of the challenges, right? We said that there's limited to no IT staff, and processing the data in place is important, right? We also talked about the challenges that infrastructure teams must address. That growth of the infrastructure, whether it's storage or just complexity, is just going to continue to grow. And somehow we need to figure out ways to simplify that. And organizations are looking at vendors to help solve those problems. And also scaling is a key here. So using infrastructure as code is a key, or ease of deployments is also definitely an area to focus on. And then finally, we touched on hybrid cloud deployments and then processing that information in place. So those production applications are running in public and cloud and private clouds, as well as hybrid environments. It's important to kind of have that full story in order to understand how to best deploy within organizational environments. And Craig, before we end today's session, I'd love to give you the last word. I know you have a lot to say on this topic, and I just want to give you the last word. I know we just touched on a little bit here, so I just want to make sure that you have a say here.
No, I appreciate that. I've enjoyed the conversation immensely. Every single time we talk, there's something new that I learned, so I appreciate that. But I just want to say, edge computing is, like you said, Paul, it's growing like crazy. Despite its growth, it's still a pretty nascent area, I would say. And even though it's early days, we are seeing some overarching themes that are just common challenges that everybody's facing. So I think we do have a really great solution to address those challenges, and just welcome everybody in the audience to come to scalecomputing.com. Check out our demo. We'll have to walk you through the product. As I mentioned earlier, we call it HE150 trial promo. So that's based on this small form factor. We can get you a handful of nodes to have in your environment, test out. Seeing is believing, as I say, and I would say that, we talk about ease of use. We absolutely mean it, put our brand behind that. So appreciate the time today.
Craig, thanks a lot. It's been great. And thank you to the audience for attending, and also to learn more about what we're talking about, because we just touched on a little bit here. This is just a lot more to talk about here. Please visit the attachment section below to find some more resources. Thank you again for your time.